Good morning, sir.
Morning.
Good morning.
How's everybody doing today?
Pretty good.
Good.
All right. Well, let's get the show started then. All right, here's your last exam. Let's check it out. Number one, George leases a machine for his business. He pays an initial fee of $1,000 and then a maintenance cost of $115 a month. Okay, so A, write a function C of X that calculates the cost of leasing the machine for X months. So C of X, C pays initial fee of $1,000 and then 115. Oops. Per every month. So it's $1,000 plus 115 times the number of months. So that's your C of X function. How much is he paid at the end of 1 year? Well, since it's maintenance cost of months, 1 year is going to be 12 months. So we need to plug a 12 in for X. We have 1,000 plus 115 times 12, which is, let's see here, 1,000, 115 times 12 is 1,380. So that gives us $2,380. All right, does that make sense?
Yes, it does.
Okay. I think one of the mistakes people probably make is putting a 1 right here since it's 1 year instead of a 12 to remember that it's in months. All right, number two, find and interpret the y-intercept. If you plug a 0 in, you're left with simply 99 here, right? So y-intercept would be the point 099. Interpret it. Let's see, it's a linear function. It models the cost C in dollars of renting a DVR for T months. So that's what you pay at 0 months. So that's like a one-time fee, right? One-time fee. It could be like installation, maybe. Right? Whatever fee it is. It might be the shipping and installation. Who knows? But it's just a one-time fee. All right. Find, interpret the slope. All right, your slope here is the number that's being multiplied by your variable. So it's 5.99. See, that's the cost for renting a DVR for T months. That's your monthly rental cost. All right, you're paying $5.99 a month to rent the DVR. And how much will it cost to rent this DVR for 2 years? Well, since this thing is in months again, 2 years is 24 months. So $5.99. It's 24. It's 99. So let's see, 5.99 times 24. So it's 143.76 plus 99. gonna be 242.76. All right, any questions about this?
No, sir.
Okay. Let's go on to our quiz. Let's see, I'll pick a couple of problems from page 89 again. Let's go with this one. Number 1. Two, let's see. So we have room for this. There. All right, let's see. It's 10:37. 15 minutes, 47, 50, 52. We'll come back at 10:52. Get your breakout rooms going. All right, class. Y'all back with me here? Hello? Anybody there?
Right here.
Yes.
All right. All right, let's check out this quiz here. Find the current minimum wage in Seattle and San Antonio to answer the following. All right, did y'all look that up? Let's see. Do some Googling here. Minimum wage in Seattle. God damn it. Minimum wage in Seattle. 21. So Seattle, I found is 1669. Let's do San Antonio. What's the minimum wage in San Antonio? Anybody know? Minimum wage in San Antonio, Texas. $7.25. Damn, theirs is more than twice ours. All right, how much would you get paid for working 40 hours in each city at these rates? Well, Seattle. Yeah, okay, we have 1669 times 40 would be 667.60. And San Antonio, 725 times 40. $290. That's a substantial difference, isn't it? My guess is housing and stuff costs a lot more in Seattle, but I've never lived there, so I could be wrong. All right, what other compensations does the spell to take into account? Living costs. They might have higher taxes. Let's see, I want to say groceries, but I want to say more than just groceries.
I put food also and gas because it is expensive up there.
Food and gas. prices. All right. And apparently all drugs are legal there. No matter the quantity, it's all been decriminalized, which is what the World Health Organization has been pushing for since 2014. All right, number 2, the charges for traveling on a certain toll road are computed by starting with a base charge of $1 and then 5 cents per mile. Explain how you would find the total cost. Okay, well, we'd start with $1 and then we'd multiply 5 cents times the miles and add those together. So if we fill in the chart at 0 miles, the cost would be $1. At 5 miles, we have 5 times 5 cents, 25 cents and $1, be $1.25. At 10 miles, we'd have 50 cents plus our dollar, so it'd be $1.50. At 20 miles, we have 20 times 5 cents, which is $1 plus the original dollar. At 30 miles, we'd have what, $1.50 plus $1 would be $3.50. For X miles, we have 1 plus 0. Sorry, not 0.5. 0.05 X. All right, so here we go. C, if Claudia was charged $2.45, how far did she drive on the toll road? All right, so this is our function here, right? That's our cost function. All right, I'm going to put it here. C of X equals. So they're saying the cost was $2.45. So we're going to replace this with $2.45 and solve for X. $2.45, 1 plus 0.05X. So we just solve for X. Does that make sense? Just 145 equals 0.05X. So X equals 145 divided by 0.05. So 1.45 divided by 29 miles. Should put in miles. All right, and we can of course check 29 miles at 5 cents a mile is $1.45. Add $1 to that, and we get our $2.45 back. So D, which would be greater, the number of miles driven or the total cost? Well, it depends, right? Let's see. Should be greater, number of miles driven or the total cost. Well, at 29 miles, our cost is $2.45. Let's see. Let's see, what would it be to say 1,000 miles? At 1,000 miles, multiply that by 0.05, that gives us 50. The miles is always going to be more, right? Except for, let's see, except for right here. When it's 0 miles, the cost is 1. Other than that, your miles is always more than your cost because it's only 5 cents per mile. So miles is bigger than cost, except at 0 miles. All right, we can just look at our chart here and see 5 is bigger than that. This is bigger than that. This is bigger than that. This is bigger than that. 0 is less than 1. And that's if you're comparing miles to dollars. Comparing miles to cents, that's a different question, right? Because this would be 125 cents. 125 is bigger than 5. All right, any questions about this quiz?
Nope.
All right, I'm gonna turn my air conditioner down. Okay. So we left off. Right around here, we did that, and we did that. All right, we're on page 100 now. So we're gonna graph x squared minus 4. Remember last time we just graphed x squared, and x squared looked like this. Okay, so now we're doing the same thing, except we're subtracting 4 from everything. If x squared looked like this, subtracting 4 from it, remember the output is how far you go up or down, right? If you subtract 4 from everything, you're going to end up with that. This is all going to be moved down 4 units. So let's fill out the chart and see how this happens. So at -3 squared is 9. And then -4 would be 5. -2 squared would be 4, -4 is 0. -1 squared is 1, -3 is -3. 0 squared -4. 1 squared -4. 1 -4 is a -3. 2 squared is 4 -4 is 0. 3 squared 9 -4 is 5. Notice they're the same numbers. Okay. So at -3 we go up 5. At -2 we're at 0. -1 we go down 3. At 0 we go down 4. At 1 we're at -3. At 2 we're at 0. At 3 we're up here at 5. So like I said, it looks exactly like the graph of x squared, except everything has been moved down 4 because we subtracted 4 from our x squared. Does that make sense? Yeah?
Yes.
All right, good. All right, and we just discussed that. Here, I'll draw it on there. This is x squared minus 4 and blue here. This is x squared. Move down 4 units. Page 101 here. So a quadratic function is of this form: ax squared plus bx plus c, where a, b, and c are numbers, x is your variable. They say a is not equal to 0, because if a is 0, you're left with a linear function. Okay. So they give us a parabola. A quadratic function, when you graph it, makes a parabola. All right, so each parabola below, label the following: the vertex, the axis of symmetry, the y-intercept, the x-intercepts, and the maximum or minimum. Okay, the vertex would be this point right here. All right, so I'll put a V for vertex, would be 0, -2. All right, the one on the right, that's our vertex. I'll use V again. That is at 5 up 9. All right, those are the vertexes. Okay, the axis of symmetry on the left, right down the middle here. Let's see, axis of symmetry is the line right here. X equals 0. It's this line right down the middle. For that line, the X values are all 0. Right? Any point on this line, the X value is 0. So the axis of symmetry is X equals 0. Over here, however, our axis of symmetry is the line, let's see here, X values are all 5 here, X equals 5. That line, X equals 5. Every point on that line has an X value of 5. All right, now back to the left one, the y-intercept. There's our y-intercept. That's where it crosses the y-axis. Y-intercept. It happens to be the same as our vertex. However, on the right, it's off the chart here. All right, it probably, see, it probably does cross the y-axis. It's just somewhere down here. Okay, so we can't see it, but it does have a y-intercept. All right, x-intercepts, let's see, on the left we got one here and one here. So x-intercepts, we have one at about a -1.5 and another one at a +1.5. Those are the x-intercepts. Here, I'll do a little squiggly. Now on the right hand side, we have 2 of them again. So here's one at 2, 0. There's another one at 8, 0. All right, maximums or minimums. The one on the left, the maximum is infinity. It goes all the way up forever, right? The minimum, however, when they say max and mins, they're talking about the y values, the output of the function, the f, if you will. The minimum is at a -2, where the vertex is. So on the right here, our max is at 9. Our minimum is -infinity because this thing goes down forever. Any questions?
No, sir.
Okay. So those are the properties of a parabola, basically. All right, so let's consider this. Remember, here's your parabola. ax² plus bx plus c. All right, remember x² looked like this? Look like that, right? So that means it opens upwards. When I write x², there's really a 1 here. We just don't write that. All right, the parabola opens up if a is positive. So if this number right here is positive, it goes upwards. So if you had -x², that means anywhere you used to go up, you'd go down. So if you took all your y, these are your old y values. If you made them all negative, everywhere you used to go up, you go down. So a negative x squared would look like this. Okay, so if your a value is negative, it's going to open downward. Okay. The axis of symmetry, your line of symmetry, right? How do we find this guy? All right. Well, the axis of symmetry always goes through the vertex. You see that? Here's your vertex. All right. Well, your vertex happens to be at negative b over 2a. Remember in the last class they said the vertex formula. All right. So your vertex formula is well, your vertex, the point is going to be at negative b over 2a. Let me make sure I remember that right before I ingrain it into all y'all's heads. Yeah, negative b over 2a. Negative b over 2a, that's your x value. Well, let's write this correctly. Your vertex formula is exactly this. X equals negative b over 2a. So let's see. What would be your y value though? Oh, that is your y value. All right, find the y-intercept. If you plug a 0 in, all you're left with is the c here, right? So the y-intercept is going to be 0c. Okay. So sketch 3 different examples of a parabola that has 1, 2, or no x-intercepts. There's none. There's 1. And here's 2 x-intercepts. All right. Find the x-intercepts by solving f of x equals 0. We'll learn how to solve such equations in later sections. Okay, so if our f of x is ax squared plus bx plus c, all right, if we take this guy and we make it 0, how do we solve for x? Okay, they say the domain is all the possible x values that you can plug in where you actually get something back. Okay, we'll talk about this here in a second, solving for this. Go back to this. All right, the domain is all the x values where you get a number back. Okay, I should say a real number. Okay, so the domain is for this guy, it's all real numbers. You can plug any number you want in here for x. All right, you can plug a negative number in, you can plug a positive number in. It doesn't matter. You square it, multiply it by a, multiply it by b, and add that to c, add all that together, you're going to get a real number back. Okay. Your range here Are they still talking about these up here? Maybe they're still talking about these. So up here, notice these arrows, they keep going up forever, right? That means if you zoom out and zoom out, notice how that's also going to the right and to the left a little bit. All right. This things will eventually go infinitely far to the right and infinitely far to the left. Okay. You just have to keep going up higher and higher. The higher you go, the further to the right you've gone and the further to the left you've gone. All right. So the domain is your X values, your left and right. It does go infinitely left and infinitely right. So the domain is all real numbers. Same thing with the graph here on the right. All right. These arrows are going to the right and the left. If we kept going down forever, you would eventually make it infinitely far to the right and infinitely far to the left. So your domain is the left and the right. So you can plug in any real number and you're going to get a number back. The range, however, is the output. Here, your range, your Y values, all right, it goes from -2 to infinity, okay? So you basically have everything above that line. So -2, I put a square bracket because we do include -2. All right, I put a round bracket if I was like everything up to -2, not including -2, but we want to have a square bracket here because the graph does touch -2. On the one on the right here, our range is at 9. Then it goes down to -infinity. So the domain is your left and your right, and your range is your up and your down.
Hmm.
So over here, I'll put domain. I'm going to put funky R. That stands for all real numbers. See, some functions have a limited domain. Think about like, what if I had g of x equals the square root of x? All right, you can't take the square root of a negative number. It doesn't make sense. All right, because like the square root of -1, what can you square to get a negative number? Nothing, right? Because if you square anything, if you square a negative number, you get a positive number. So if you plugged a negative number in here, it wouldn't make any sense. Okay, so for this g of x, the domain wouldn't be all real numbers. It would be 0 to infinity. You can only plug in positive numbers or 0 into this function, right? But quadratics, you can plug in any number you want. And so you can square any number you want. You can multiply any number you want by b, and you can add those together, and you're going to get a real number back. All right. Oh. Now, find the x-intercepts by solving f of x equals 0. All right, well, these up here, we just looked at the graph, right? Well, what if they gave us a function instead? What if they gave us like this? And they wanted us to find the x-intercepts. Well, we could graph it and then like eyeball the graph and guess kind of where the line crosses the x-axis. But to do it mathematically, we'd have to set this equal to 0 and solve. Okay. So the way you do that, there's several methods. I don't remember if y'all remember factoring, right? Remember if you have something like this, y'all remember this stuff?
Yes.
All right, so we have to do this stuff backwards. Like if we multiplied this out, we're gonna have an x times an x. We got an x squared. We got a 2x. We got an x, and then we get a 2. So this is x squared plus 3x plus 2. So this is a quadratic, but we can factor it to look like that. All right, so if we're setting this thing equal to 0, right? If they give us this and we're solving that, we'd go backwards and turn it into this. Once you have that, you set each one of these separately equal to 0 and solve. That's one way to do it. But not everything is easily factorable. So what you do, what always works is using the quadratic formula. All right. So the quadratic formula. When you have 0 equals ax squared plus bx plus c, what does x equal? Let's see, if you solve this, it's like, what is it? Negative b plus or minus the square root of b squared minus 4ac all over 2a. I think that's what it is. All right, and I could show you how you actually solve this, how you actually factor this guy. You have to do completing the square, okay? But I'm not gonna force y'all through that today. All right, I'm just gonna make sure y'all can remember it and use it. Notice there's two solutions here, one with the positive and one with the negative. It's because there's an x squared. That means there's two solutions. So your x-intercepts are going to be at your 2 points here. You got negative b plus the square root of b squared minus 4ac all over 2a, 0, and negative b minus the square root of b squared minus 4ac all over 2a and 0. Those are your two x-intercepts. Sometimes these can be the same thing. Like if this guy is just 0, all right, then you're going to get the same number, okay? Like if you have x squared, if that's your function, then your b and your c are both 0. If your b and c are 0, then this guy is 0. So that's why when you graph x squared, it goes through right here. There's only one x-intercept instead of 2. Okay. All right, let's see. Use the vertex and whether the graph opens up or down to determine the number of x-intercepts. Sketch the graph. Okay, our vertex formula here, it's going to give us our axis of symmetry. Axis of symmetry is where x equals negative b over 2a. Our b here is 5, and we have 2. Our a here is a 1. We just don't write it here. I'll write it just because. So we got a negative 5 halves. So over here at negative 5 halves, see, what is that? 5 halves is 2.5, right? So 1, 2, 3. So kind of, well, let me use the grid for crying out loud. The line straight, pretty. All right, 1, 2, 3. So at negative 2.5, that's where axis of symmetry is. Okay. Oh, does it open up or down? It opens upwards because this is a positive. And how many x-intercepts will there be? Well, let's graph this thing. X squared plus 5x plus 4. Let me cheat here. All right, how do I add a function? insert. There we go. Oh, hell, what was our function? X squared plus 5x plus 4. X squared plus 5x plus 4. Okay, how do I get snip? New. I'll use this tool here. Rectangular snip. All right. We'll do that one next. So this one there looks like. So right here at, see, this would be 3. So at 2.5, where that is, it opens upwards. I figure out how to get the Y value here. To get the vertex. Hold on, give me a second here. Okay. Now I remember. All right, so our vertex, the X value for our vertex is given by this. All right. The Y value, how far you go up or down, you have to take this and plug it into your function. So we take f of that, of course. So if we plug this in, right, from our vertex formula, that's the X coordinate. To find the Y coordinate, simply plug it into your function. So we got -5/2 squared plus 5 times the -5/2 and then 4. So we have, let's see, 25/4 minus 25 seconds plus 4. Okay, let's get a common denominator. This is 50/4. And this would be 16/4. So 25 minus 50 is a -25, and then 16. 9, -9/4. All right, so our vertex is at -5/2. That was the -b/2a. You plug that into your function to get the Y value, and we found that it's -9/4. So that point right there is this point right here. That's our vertex. So because our vertex is below our x-axis, and we know that it opens upwards because this guy is positive, we can tell that we're going to have two x-intercepts. Okay. All right, let's do another one here. Number 2. All right, vertex formula. Well, let me write it out. X value of vertex. This is also axis of symmetry. X equals negative b over 2a. So our b here is -3. So we got a -3. And our a here is 1. So that gives us a +3/2. All right, so I'll just graph this guy with the software so it looks nice. X squared minus 3x plus 10. X squared minus 3x plus 10. Okay. Snipping tool. Dang it. Hold on. Back. Snipping tool. New rectangular. How do I get to paste this thing? Hold on. Paste. Yeah, that's it. There we go. So the x value of the vertex, we have 3/2. All right, that's the same as 1.5, right? So here's 1, here's 1.5, right? So that's x equals 3/2. All right, here's our vertex. All right, so we know the x value of our vertex is 3/2. Now to find the y value, we do f of 3/2. All right, so if we plug that in, we have 3/2 squared minus 3 times 3/2 plus 10. So 9/4 minus 9/2 plus 10. Common denominator here. So 9 minus 18 is a -9 plus 40 would be 31/4. Let's see, 7 times 4 is 28, right? So this is 7 3/4. All right, 7 3/4. So you can tell that we're up here at 7 3/4. All right, so that's how you find your vertex. All right, since a is 1, which is positive, that means it opens upwards. All right, so since our y value of our vertex is up here, right? Since 7 3/4 is positive, all right, that means we're above the x axis, and since a is positive, which means it opens upward, both of those tell us that there are no x-intercepts, right? Here's your x-axis. It's not crossing the x-axis because your vertex is up here above the x-axis and it's opening upwards. All right, does that make sense here? I know it sounds like a lot of information, but it's really not. There's just the vertex formula and plugging what you get into f to get the y value. These two numbers and interpreting them. So we have a negative b over 2a and f of negative b over 2a. All right, let's take a break. We'll do another one of these when we get back. We'll take a 15-minute break. It's 11:37, so 11:47, 11:52. We'll come back. All right, class, we're back. Let's look at another one of these problems. Are y'all there with me?
Yes, sir.
All right. So let's use our vertex formula again. Well, let's just graph this thing first off. What is it? Negative x squared plus 10x minus 25. Need a negative in there. Negative x squared plus 10x minus 25. Zoom out. Go down. There we go. Let's take a snapshot. Rectangular snip and boom. Okay. So you can see here, here's our vertex, right? It's at 5, 0. All right. But what if we couldn't just look at the graph and see that? Using this over here, let's figure out what our vertex is. All right, so vertex. So for the x value, it's negative b over 2a. So b here is 10. A is a negative 1, right? A is negative 1. B is 10. So we get 5. Right? So that's the x value of our vertex. To get the y value, we do f of 5. That's negative 5 squared. It's 5 times 10 minus 25. So we have negative 25 plus 50 minus 25 is 0. That's the y value for the vertex. All right. So since the vertex lies on the x-axis, right? And a here is negative 1, which is negative. That means it opens downward, okay? So we can see that it goes down. All right, but because it lies on the x-axis, the vertex, since f of 5 is 0, we're on the x-axis, therefore we only have one x-intercept. Only this one right on the vertex, okay, or on the x-axis, okay. We can see down here, here's our y intercept, right? Remember, to find your y-intercept, you let x be 0. X be 0. F of 0, you replace x's with zeros, you're just going to get a negative 25, right? So this point here is 0, negative 25. Okay, so usually you can find your vertex and then plug 0 in, so you're just looking at this number. So that'll give you another point. Once you get these 2 points, you can kind of know what it looks like. Be like, it looks like that. Okay. So that's the fastest way to figure out what your parabola looks like. Get your vertex, boom, and then look at your C value, because that's going to be where your y-intercept is. Okay. Those 2 points give you an idea of what your graph looks like. Okay. your axis of symmetry always goes through your vertex, right? Axis of symmetry is at x equals 5. Okay, any questions about this?
It's a little confusing, but just the more that we do it, the more,
More it becomes clear, right?
right?
Yeah, same here. All right, let's see. Use these graphs to answer the questions below. Okay. All right, the axis of symmetry for graph A goes right through here. That's at x equals 3. All right, for graph B, goes through here, that's at x equals -2. Okay. Now, what are the vertexes? Graph A, it's right here. What is that point? 3, 4. 3, 4. For graph B, it's right here. This point is what? -2, -5. What else do I got lots of questions here. Okay. All right. Is there a maximum or a minimum? All right. This guy on the left, the maximum is 4. The highest it goes up is at 4. There is no minimum. It goes down to -infinity. Okay. On the right here, we have a minimum is at -5. The maximum, since it goes up forever, is +infinity. Okay. Domain and range. All right, the domain of both of these is all real numbers. Domain is all real numbers because it does go infinitely to the right and to the left. Okay, both of them do. All real numbers. All right, the range here is how far you go up or down. All right, so the highest we go is 4 with a square bracket. And this is interval notation here, by the way. And then we go forever downward. All right, the one on the right. All right, our interval here. The lowest we go is -5, but we go infinitely far upward. Okay, so this is an interval here, not a point. All right. Y-intercepts, looks like it's right here. Intercept is at 0, -5. This guy, Y-intercept is at 0, -1. All right, explain how 6, -5 is related to our answer. 6, 5, 6, -5. That's opposite our y-intercept. Okay, so whenever you use the vertex formula, you get this point. Then you can just look at your C value to get this point. Once you have that, you kind of know what this one is, all right? Because you know the distance between here and here, just go that much further over, all right? All right, so we were at 3 for our x value. This point has an x value of 0, so it's a difference of 3. So just add 3 to that. That gives you the 6. So then you get this other point here. Then you can easily draw your graph. Okay. So over here on the right, they're going to ask us about this point. Right. Well, the distance between our vertex and our axis of symmetry here is 2. So that point there is going to be at a -4. Still at not negative, whatever this point is, -1. All right, you can look at it and see we're going to the left 4 and down 1. Once you get those 3 points, it's easy to draw your graph. Do some more examples. All right, sketch the graph and identify the characteristics. All right, so does it open up or down? Well, that's the A here is 1, which is positive, so it opens upward. Our axis of symmetry is at -b/2a. So we got -6 over 2 times 1, so that's a +3. So over here at 1, 2, 3. There's our axis of symmetry. The vertex, all right, the x value is 3. So to find the y value of the vertex, we look at f of 3. So we got 3 squared minus 6 times 3 plus 13. That's 9 minus 18 plus 13. -9 and 13 is 4. So our vertex is at 3, 4. So we go over 1, 2, 3 and up 4. Boom. There's our vertex. All right. Now to find our y-intercept, we plug in 0 for x. We're left with just 13, right? So our y-intercept here is 0, 13. So up here, 10, 11, 12, 13. So we know this guy looks like this. All right. If we look at this, the distance from here to here is what, 3, right? So if we go 1, 2, 3 over here, basically we're like right here for our other point, right? See, this point is 0, 13. So this point over here is going to be 3, 13. That's the point that's, I guess it's, I don't know what to call it. It's its counterpart, basically. How many x-intercepts? Well, since the vertex is above the x-axis and it opens upwards, there are no x-intercepts. It does not cross the x-axis. The domain, it's always all real numbers, right? Because again, the arrows, they're pointing upwards, but they're also kind of pointing to the right and the left. So if you keep going up, the arrows keep going right and left. They'll eventually go all the way to the right and all the way to the left. So domain's all real numbers. Range is all your possible y values. All right. The smallest y value here is 4. And since the arrows go upwards, they go to infinity. So these are the numbers you can plug into the function. These are the numbers that come out of the function, all your y values. Questions?
Just letting it soak in.
Little bit surely, right? All right, let's look at another one here. All right, our A here is a -1, which is negative. So it opens downward. Our axis of symmetry is that x equals negative b over 2a. So negative negative 2 over 2 times a negative 1. So this is negative 1 because there's 3 minuses and 2 over 2 is 1. So at negative 1 here, that's our axis of symmetry. So our vertex is going to lie on that line. To find where at on that line, we just need to plug our negative 1 into our functions. We got a negative 1 squared minus 2 times a negative 1 minus 1. So we got 3 minus signs here, which is a negative 1 plus 2 minus 1, so that's 0. So the y value, the vertex, is at negative 1, 0, negative 1, and 0. So right there's our vertex. The y-intercept, we plug 0 in for x, right? We're just left with this minus 1 here. So 0 minus 1. There's our y-intercept is at 0 minus 1. All right, so this thing looks like this. All right, no, it looks like this. It opens downward. Okay. So knowing this point, that tells us we also know that point. Okay. So that's what it looks like. The number of x-intercepts, since the vertex is on the x-axis, there's only one x-intercept right there on the vertex. The domain, all real numbers, because the arrows do go infinitely to the right and infinitely to the left. The range is your y values. We're starting off here at 0. I guess I should do it this way. Negative infinity up to 0, right? Square bracket on the 0 because this point is on the x-axis. All right, we are including 0. You'll know your interval notation, right? So like a 2, 3, this is all the numbers between 2 and 3, but not including 2 and 3. If you do this, this is all the numbers between 2 and 3, but also including the number 3. All right, so square bracket includes the endpoint. All right, it's important to have that down. So this is how you graph a parabolas. Okay. Find another point to plot using the y-intercept. We already did that. Okay, the mirror image. That's the term I was looking for. That's this one. They're mirror images of one another. Okay. All right. So our A here is a negative 1, is negative, so it opens downward. Axis of symmetry, negative b over 2a. We got a negative 4 over 2 times negative 1. So this is a positive 2. So over here at 2, there's our axis of symmetry. Our vertex lies on this line, but how far up or down do we go? Well, we plug 2 into our function. Got a negative 2 squared plus 4 times 2 plus 3. It's a negative 4 plus 8 plus 3, which is 7. So our vertex here is at 2, 7. Over 2, up 7. Boom. There's our vertex. All right. So it opens downward. It could be like this. It could be like that. To figure it out, we look and find our y-intercept. If we plug 0 in for x, that goes away. We're just left with a 3, right? So our y-intercept here is at 0, 3. 0, 3. All right, since we know that point, we know this point. Looks something like that. How many x-intercepts are there? There's 2. One right here and one right here. Where they actually are, all right, is a little bit harder to do. We'd have to set this thing equal to 0 and solve for x, and that's when the quadratic formula comes into play, or you do factoring. That's a little bit harder, but it gives you a more accurate graph. Okay, so we'll do that later. Our domain, all real numbers, because it goes infinitely right and left. The range here, we're up here at 7, and we go down to negative infinity. So everything from negative infinity up to 7. To get an easier, let's do another one. Okay, our A here is a -3, which is negative, so it opens downward. Our axis of symmetry is at -b/2a. So we have a -30 over 2 times -3. So 30/6 would be 5. So at -5, here's our axis of symmetry. Now, where does the vertex lie on that line? We have to take our -5 and plug it into our function. So we got -3 times a -5 squared minus 30 times a -5 minus 82. So -5 squared is 25 times a -3, which would be a -75 plus 90 minus 82. So that's -75 plus 8, which would be a negative 67. Is that right? I'm doing something wrong here. They wouldn't give us ugly numbers like that. -5, -3 times -5 squared minus 30 times a -5 minus 82. All right, 5 squared is 25 times -3. It's a -75. -30 times, yeah, this is wrong. -30 times 5 is about 150. There, that's a little more reasonable. So, like that. 150 minus 82 minus 75 is -7. So our vertex is at -5, -7, right? It's on our axis of symmetry, but it's down here. So got to go down 7. Boom. Axis of symmetry. This thing is opening downwards. Our y-intercept, plug 0 in. It gives us a -82. So y-intercept is way down here. Further than that, but I'll say this is at -82. Okay. All right, so it's going to look like this. Number of x-intercepts, 0. Our vertex is below the x-axis, and it opens downward, so no x-intercepts. Domain, all real numbers. The range, we're all the way down at -infinity, but we go up to a -7. Okay. All right, there's our homework. All right, let's do one of these here. right. Answer the following. An object is launched directly upward at 19.6 meters per second from a 5.58.8 meter tall platform. The function for the object's distance from the ground d at time t seconds after the launch is given by this formula, where d is in meters. When does the object strike the ground? All right, well, let's look at this thing. This is a distance. So an object is launched directly upward, and it starts off at a 58.8 meter tall platform. So I think it's something like this. Here's 58.8, and then it's launched upwards. So we're up on a platform, we launch it upwards. This is d of t, this is t. So this function tells us the distance from the ground. So you can see that at time 0, if you plug a 0 in for t, you're at 58.8. That makes sense because we're on a platform that's 58.8 meters tall, right? The a here is negative, so that's why our parabola opens downward. See? All right. When does the object strike the ground? Well, we'd have to say, we'd take our formula here, negative 4.9 t squared plus 19.6 t plus 58.8. When is it hit the ground? It hits the ground when the distance to the ground is 0. All right. So it strikes the ground when d of t is 0. So we'd have to actually solve for the time here. That means using the quadratic formula. I don't think they want us to do that right now. I think they're just saying when d of t is 0. That's what they're asking for. Okay. The speed of the object is measured in which units? Meters per second, right? Meters per second. How tall is the platform? They tell us right here, it's 58.8 meters. Write the function that models this problem. They gave it to us right here. That tells you the distance to the ground. D represents basically distance to the ground, or height. And the distance is measured in which units? D is measured in meters. What is the question being asked? When does it strike the ground? When d of t is 0. All right, so that's what they're trying to find out. They got the formula, tells the distance to the ground at a given time. They want to find out when will the object hit the ground. Okay. So these are the kind of problems we're going to be messing with here. Let's do one more. This is what quadratics or parabolas are good for, these types of physics problems. All right, a ball is thrown into the air. The height of the ball above the ground is represented by this function, h of t, where h is in feet and t is in seconds. So the speed of the object is measured in which units? Since it's thrown in the air, since the height is in feet and t is in seconds, the speed is going to be in feet per second. Okay. What does the variable h represent? H is the height. T is the time. H is measured in which units? Feet. The variable t is time. It's measured in seconds. sketch the path of the ball. Let the x-axis measure time. And so, yeah. This is h of t. This is t. All right, so if you notice here, if you plug 0 in for the time, that would be 0, that would be 0. So they're starting off at a height of 0, right? H of 0 is 0. So you're starting off right here at the ground. The height of the ball above the ground. A is negative, so it opens downward. Let's find our vertex here. Vertex. X is negative b over 2a. So that's a negative 8 over 2 times a negative 16. So that's 8 over 32. 8, so that's about 1/4. So let's go here at 1/4. All right, so that's our axis of symmetry. So at 1/4 of a second is when it's going to be at its maximum height. What the maximum height is going to be, we need to plug 1/4 into our function. We got negative 16 times a 1/4 squared plus 8 times a 1/4. So this is negative 1 plus 2 is 1. It's going to look like that. So at 1/4 of a second, you're going to be at a height of 1 foot. So that's kind of what the graph looks like. That's what this function tells us. Not much of a throw there, right? All right, let's, is the graph a line or a parabola? It's a parabola. We have a squared here. So yeah, it's a parabola. All right, let's do our exam. This is exam number 12. Let's see. We'll do these. Do number 2 here. It's going to be our number 1. How can I put both of these on one page? Well, let me think about this. Do number 1 and number 2. So we'll have 2 and number 3. I guess I have to do them on separate pages, don't I? So there's your number 1, y'all. Let me do number 2 on the next page. All right. Y'all got screenshots of number 1 already?
Yes.
All
Yep.
right, there's your number.
I didn't.
Okay. And this will be posted in the files, remember, in your lecture notes on Canvas right after class. Okay, so you can also get it from there. So there's 2 problems here.
Thank you.
And there's your number 2. All right, folks. That's it for today. I'll see y'all Wednesday.
Have a good day, sir.
Have a good one.